Now, Artemis II. The crew spending its last full day in space, packing things up, getting ready, securing everything for expected splashdown off the coast of, my hometown, San Diego, tomorrow night. Along the way, the world has been captivated. I've been captivated. You've been captivated by so many stunning images like the ones you are seeing now. But there might even be a bigger payoff than those amazing pictures. What is it? What could it be? Well, lots of experiments conducted. One of them is really fascinating. And it includes, you see it right there, carrying computer chips that contain the astronaut's bone marrow. And there is hope that evidence collected from this particular experiment could reshape the practice of medicine here on Earth and tell us more about what it would be like to live for a long period of time in deep space. Earlier, I spoke to Donald Ingber, who is the founding director of the Wyss Institute for Biologically Inspired Engineering at Harvard University. His laboratory was a key collaborator with NASA on this very experiment. Listen. Don, many wonders have come from the Artemis II mission. Among them, USB thumb drives, bone marrow cells, and the crew. Explain to my audience what this wonder is about.
Well, the USB thumb drive is describing the size of a small device we call a human organ on a chip, which is lined with hollow channels, and that itself is lined with living human cells from the astronauts that's flying with them around the moon.
And the value of those bone marrow cells on these USB thumb drive sized chips is what?
Well, the idea is to use them to assess the effects of spaceflight, microgravity, and particularly radiation that the astronauts experience. And it's really a proof of concept study to see if we can use these. And again, we've matched them with the astronauts. It's the astronauts' own cells. We have these chips both in space and on the ground in parallel, and to see if we can determine effects on the cells of these astronauts using these devices. Right now, we only have a handful of chips, but in the long term, if this is proven to be useful, we can send up many chips to the, in space flights as well, potentially on the moon someday, to really get larger numbers and to get greater statistical significance and insight into the effects of living outside the atmosphere and on distant planets, and in the long run, developing countermeasures that may be protective.
Because as you said, there's microgravity, partial gravity, and all these different forms of radiation. And we don't know that much about them. And if we're going to envision prolonged human exposure on the moon or maybe eventually Mars, we've got to know what these effects are, and these chips are a way to get there.
We not only need to know what the effects are, we need to be able to develop countermeasures that protect. The radiation is the most dangerous, and it's it's uncontrollable. A solar flare that could happen erratically can be really, really dangerous. And so, yes, it's hard to get insight into how these conditions in spaceflight impact the human body 4 astronauts at a time. But with these chips, in the long term, we may be able to literally use them as avatars and have many of them to explore, men, women, different ethnic groups, genetic subpopulations, and figure out, who might be affected the most, the least, who we need to protect the most. And also on Earth, we use these to develop new drugs. And so we may be able to, if we understand the mechanism or the injury response, we may be able to develop new drugs that could protect in the future.
So just on that point you made, Don, this is not only about living in space, it's about improving life potentially on Earth.
Absolutely. The effects of microgravity are muscle and bone wasting, which is very similar to what you see with bedridden patients. If you had countermeasures to protect against that, it could be useful on Earth. Protecting against radiation obviously could be useful on Earth to protect, healthy tissues against cancer radiation therapy, or in the case of a major nuclear accident.
Walk my audience through what's going to happen after splashdown, because lots of people are going to be dealing with the data collected.
Yeah, so my team has been, they were at the Kennedy Space Center for the launch, and then they're going to be collecting the samples that will be taken, and we fix them to freeze the tissues in place in San Diego, and they pick them up from the landing, and they'll be all transported back to Boston, where then all the analyses will be carried out to determine whether there are effects on the chromosomes, on inflammation, on injury to cells, and by comparing the ones that went around the moon and the ones that were on Earth. And we've also had blood samples from the astronauts before and after, and so we'll be comparing the results that we see in the marrow to what we see in the blood cells in the circulation, which are produced by the marrow.
And how long will it be before your team knows what it has learned?
That's going to take many months probably to do all the analyses. We're going to be following up for a number of months with with astronaut blood samples to really do all these comparisons. But once again, this is really a proof of concept study. Can we keep these alive? Do they look anything like the individual astronauts? Can we see difference between different astronauts? And it's really the future where we get much more useful information when we put bigger numbers out there.
And if the concept is in fact proven, it could be electrifying here on Earth and in the heavens. Don Ingber, the Wyss Institute, Harvard University. Thank you so very much. I appreciate it.
Thanks for the opportunity.
Science. Yay. You can watch special coverage of the Artemis II cruise splashdown tomorrow, beginning at 7:30 p.m. Eastern, right here on CBS News 24/7.